All right. Good evening. From 5, this is a Wednesday groups. Once again, I meet you here on Wednesday night. Okay. Hope everybody doing fine for the whole week. And also I hope you can enjoy the lesson. Okay. You have to be strong on night lesson. You need a very good discipline, self-discipline, okay, to focus and to listen. Online class is like that. You need to have really focus 100%. Especially when you cannot hear me or you cannot have a good laptop, sound system not good, internet not so stable. There's a lot of problem, I understand, okay? But everybody, you have to be strong, consistent, and most important, your self-discipline is very important, okay? Okay, let's start our lesson for tonight. Okay, come, I start sharing the paper with you. Okay, I suppose last lesson we stop here, correct? Not our last lesson we stop here. So now we left one question not discussed yet, isn't it? Question number 14, is it correct? Fansin, Kong Fansin, is it correct? We stop here?
Yes, teacher.
Okay. Now be ready now. You need to write a lot of things on this question, Okay. This question is on practical, okay? I'm sure you already know, right? Your SPM will have this practical examination, okay? Once, I believe, once you go back to school starting from April, definitely your school will let you have this practical examination, okay? It's very important, because one whole year, last year from 4, you don't have much opportunity to carry out experiment. And also this year, okay? So this year also, I'm sure you don't have much opportunity to do experiment. So meaning that the moment you go back to school starting from 5th April, you need to do a lot of practical, okay? Practical, so, all right. For doing practical, right, hands-on is one, After your hands-on, you need to collect data, you need to plot graph, you need to answer question, and also you need to write report. That's why you look at this question is important. You must know how to write the report, how to build the structure to collect the data. Okay, come, we look at this diagram now. Read the question. Figure A and B, there are two diagrams here. Okay, show two positions of a diver in the sea. Okay, on first diagram, the diver is not dive so deep inside, right? Then the ears his ear feel a little bit painful. Okay, when he go deeper, okay, dive deep inside the water, so his ears feel more pain now. Why? Actually, why now? Here, less pain, the ear less pain. When you go deeper, the painful become more serious. Okay, actually, what happened here? Why when go deeper now, his ear feel more pain? What happened actually? What is a factor affecting pain? The problem with his ears when he dive into the water? Actually, what happened here? Evangeline, what happened actually? What happened here when he go deep inside the water? His ear feel more painful. Actually, what happened? Evangeline?
Water pressure.
Water pressure, correct? Not? Yes, because when he go deeper, right, the water pressure become higher. The deeper you go, the pressure become higher. So when the pressure is higher, means the ears membrane cannot stand the pressure. So it become very painful. Understand? So very clear, this experiment is relation between what and what. Okay. Never mind. You learn how to answer the question first. First is inference. How to write an inference. The second question is how to write hypothesis. Two things, you must ready to answer, How to write inference, how to write hypothesis. Anyone can remember how to write inference? What is the keyword to use? Okay, you must be very clear now. What keyword to use to write inference? What keyword to use to write hypothesis? Any idea? Juling. Juling, can you come out?
Yes, sir.
Juling, how to write inference?
RV is based on MV.
Yes, based on, or we say depends on. We use a keyword depends on. So in this case, is a pressure. Pressure depends on the depth, right? The pressure big or small, high or low, is depends on how deep you are inside the water. So here, inference, you write liquid pressure depends on the depth. Okay, now you can copy the answer from here, Okay, so start writing like this, Okay, now you see here. So the keyword we use for inference is liquid pressure depends on the depth. Okay, the keyword is depends on. So remember the keyword. Use the word depends on. Liquid pressure depends on the depth. Okay, keyword is depends on. Okay, hypothesis, you see the keyword is the greater the depth, or we say the greater the depth, the higher the pressure. This is a keyword to write hypothesis. The greater the depth, okay, the higher the pressure. Okay, this is the relation. So remember now how to write inference, how to give a hypothesis. Okay. Okay, now. All right, third one is how to write. Third one is a must read question. You read the section C first. Okay, come go to C. C, we give you a lot of hints, you see here. With the use of apparatus such as high tin, tall tin, and rubber stopper. I believe some of you here, you don't know what is rubber stopper. Okay, rubber stopper means is things are put into a test tube to prevent the air or the water from going inside. Stop the water or air to go inside the tube. That is called rubber tube, rubber stopper. And other apparatus, so you have to think of yourself. So how to, just these two you have to use, high tin, rubber stopper, and others mean you have to think of yourself. Describe experimental framework to test your hypothesis. Okay, so first one we start is aim. You must write the aim. Okay, so remember how to write the aim, how to write variables, and so on. So remember these two, how to write aim, how to write variables. Okay, now you look at the experiment. Okay, aim is here. Okay, aim is, the keyword is to investigate. To investigate the relationship between the depth and the pressure. So this is the aim. Aim keyword is to investigate. So remember now, inference keyword is depends on. Hypothesis is the bigger this one, the smaller that, the smaller this, the bigger that, that kind of pattern. And whereas aim, the keyword is to investigate the relationship. To investigate the relationship between the depth and the pressure. Okay, next is MV, manipulated variable. So in this case, we manipulate the depth of the water. We control the depth of the water. Okay. Later on, you see the diagram, you know how you control the depth of the water. Responding variable is not pressure, no. Here, because in the experiment, Actually, we are not going to measure the pressure. We measure something else, but it's used to represent the pressure. So what we measure is the difference in the water level in the manometer. MANO, manometer. You measure the difference of the water level inside the manometer. And constant variable is the density of the water. Density of water cannot change, because it will affect the pressure also. So you want to see the relation between the depth and the pressure, right? So the density must stay constant, because density will affect the pressure. So density cannot change. Okay, now you look at the diagrams. Okay, roughly I explain to you how to do the experiment first, okay? You all must learn, because later on, you practical test, this kind of question can come out one, you must know how to do. Okay, this is a tall tin, the high tin, very tall one. So you put a lot of water inside. So put water here. And this is a distal funnel. So rubber stopper is here. So you put the rubber stopper here to prevent, because this thing going to put inside the water 5 cm, 10 cm, 15 cm, deeper and deeper. When you put this one inside the water, this rubber stopper can prevent the water from going in. So water cannot go inside. Okay? So remember now. And this is the rubber tube connecting the distal funnel to the U tube. This is U tube, but we don't call U tube, we say manometer. Manometer is a U-shaped glass tube, okay? So inside the tube, you put a little bit of water, or you can put a little bit of oil. You can put a little bit of mercury also can, okay? So what happened now, this experiment, basically what we do is like this. First, you push this thing 5 cm inside. Depth 5 cm, so you push inside 5 cm. The moment you push inside the water, because I got liquid pressure, immediately the pressure will push up and then push this water here, go down. This side go down, and then this side the water will go up. Because pressure, water pressure is high. When you put inside 5 cm, definitely the pressure is high already. So if you push this side, the water come down, here go up. So then you can have the different water level already in the manometer L. So you measure the level here. How many cm the difference? So you start with 5 cm, you measure here, go up by how many cm? Okay, the difference in the water level here in manometer. Use a ruler to measure. Then next round, you push deeper, push it 10 cm, even deeper now. In your opinion now, when you go deeper, right, pressure is higher. Higher pressure definitely will push this water go down slower, and here we go up higher. So the difference of the water level L will become bigger. So you record. So your MV is here, the depth, your RV is here. The difference in the low water level in the manometer. So in this case, we are not measuring the pressure, we are measuring this one, the difference in the water level. Here you can put water, can put oil, can put mercury, anything also can. Okay. So now you know how to do the experiment already. Can? Okay, now I'm going to copy the diagram, copy the apparatus and material, everything. Okay, please copy now. Hey, learn how to draw the diagram. You must draw. Okay, I know some of you just say, why so stupid? I take a camera, take one picture, that's all. No, cannot. If you take a pictures, mean that the pictures will forever inside your camera. Okay, it won't become a skill for yourself. During the examination, practical examination, you must know how to draw the diagram. Understand? Drawing is very important. Okay, please draw now, everybody. Okay, draw nicely. Okay. Apparatus and material, so you have high tin, this one, rubber stopper, manometer, water, of course, meter rule, distal funnel here, retort stand, and one more, the rubber tube. Please add in a rubber tube. You need the rubber tube to connect. Okay, add here, rubber tube, okay? You did the rubber tube. Okay. Okay, come. I give you a little bit time. You go and copy the diagram. Don't be lazy. Practice draw. Drawing your diagram very important one, you know. Okay, finish. Chloe, Chu, have you done? Chloe.
Yeah, chưa haven't.
Okay, come. You are doing, I know. Chloe, yeah, okay. Artie, what about you? Your Jolene haven't come in. I didn't see Jolene, sir. Now only I clip Jolene to come. Okay, Jolene got 2. Artie, how about you? Okay or not? Artie, are you doing now? Okay, good, Adi. Adi can hear lah, can hear me, can hear what I say na. Actually, we are not sure yet in your SPM examination practical. You need to do 1 or 2 experiments. We are not sure yet, because until now the ministry are not decided yet. At first, they say 3 subjects, your physics, chemistry, bio, separate days. One paper, physics, for example, 3 hours, chemistry, 3 hours, like that. But later on, because of MCO, they say not enough of apparatus. Then I heard what they say lah. They will combine 3 subjects in 1 paper. Physics, chemistry, bio. Meaning that you only sit for practical tests. The practical test become 3 in 1. But this hasn't not confirmed one, no black and white yet. They make 3 papers in 1 so that you don't need to come too many times, okay? Don't need to use so much apparatus. I don't know lah. Wait for the latest development But if 3 in 1, how they're going to give marks Definitely maybe like this law. In 1 paper, they have 3 questions. 1 physics, 1 bio, 1 chemistry. Maybe some of the apparatus sharing one can share one, The experiment can use in chemistry. The apparatus can also use in physics. Also maybe share in the bio. We don't know yet. We are not sure. I know some school already given you all the practical trial. But I think your most school they give you now is follow individual subject, not combining subject one. Like physics, do physics one, chemistry, do chemistry one. Okay, come. I think you all finished already, the diagram. Everyone finished or not? Chloe, finish?
Yeah, Joe, finish already.
Finish diagram. Adi, finish or not? Okay, now we look at the procedure. Procedure is the one you need to know how to write. Okay, procedure. Okay, basically procedure at least 4 sentences in a 4 step. First one, you always write this one. Apparatus material are set up as shown in the diagram. This is just an intro. This one no marks one. Intro. Apparatus and material set up as shown in the diagram. So you don't need to explain now. You just say shown in the diagram. Okay. Next, your first experiment you do like this lah. Distal funnel lower down into the water for the depth T equal 5 cm. So you push the distal funnel inside 5 cm. You to start now. Distal funnel lower down into the water for the depth T equal 5. Then immediately you can see the water here go down, here go up. So you measure this lah. So the difference of water level in manometer L is measured using a ruler. Use a ruler to measure the difference in the level. Okay? That's it now. First one, second one, and the last one is repetition. How you repeat the experiment. Okay? Ready? Finish or not? This one, point 1, 2, 3, finish. And then now this one carry the name Ganti one. Ganti, who is Ganti? Loganesh, is it Loganesh? Loga is from 5 or from 4? Okay, Sakti, I think it's Sakti, right? Sakti, are you here? Sakti?
Yes, sir.
Oh, you are here. Okay, come. Never mind. So this one done already. One more step to go, Come, you see. The next step is repetition. Now, how you repeat the experiment. Okay, so your experiment, you repeat like this. Okay, sorry. Okay, repetition is very important. You say, the experiment repeated using greater depth for the water. Example, you go down to 10 cm, 15 cm, 20, 25, and 30 cm. You go deeper and deeper. Okay, so third step is repetition, the final step. The experiment repeated using greater depth of water. Example, just now it's at 5 cm. So now you put 10 cm, 15 cm, 20 cm, 25, and 30 cm. Okay. Here you must give at least 4. At least 4, You give 1 or 2, it's not enough. You must give at least 4. Of course, the more you give, the better. Okay. So this one will be the last step for your procedure. Okay. After your procedure, right, the next one will be tabulation of data. So you need to present a table how you are going to collect the data in your experiment. This is something you must do in your practical test. Build a table to keep all your data, to copy down your data. So the table you need to do here is like this lah. 2 columns only. Manipulated variable must be on the left side. Manipulated variable. Okay. Responding variable will be here. Okay. Responding variable. So manipulated variable, you must write the name, the symbol, the unit. Same as responding variable lah. The symbol L, unit cm. And this 5, 10, 15, 20, 25, 30 is a must. You have to write. You know why? Because this one is your plan. You plan, so you manipulate, you control one. So you control one, you have to write yourself. Understand? It's one what you plan, you plan one all this lah. And then this one, you write down all your answer during your experiment. So you jot down here. Okay. So your table given you a lot of marks, 5 marks all together. So make sure all the value here is valid and is accurate. Okay, very important. So tabulation of data. Okay, can someone tell me next step is what? After you have the table, next one do what? Once you have the table already, next one is doing what? It's very important one. Next step is what? After you complete your table, next step is doing what? Young Chai-Ling. After you completed the table, next step is doing what? I heard. Yes, what is that?
Draw graph.
Yes, correct. Plot a graph. Bernard, you're right. So the next one is plotting a graph on a piece of graph paper. You have to do it nicely on graph paper. Okay? Understand? It's very important. Graph is very important now on graph paper. Okay? And the graph, I tell you, also a lot of marks. And make sure the graph you plot is big enough, If you plot a very, very small graph, no point one, no marks given. You already know, right? Since Form 4, your graph must be at least half of the graph paper, half page, Okay, now the problem is, what graph are you going to plot? If you have this table, so what graph you are going to plot? You must think carefully, what graph are you supposed to plot? Karin Young? What graph are
Directly
you?
proportional.
Can you tell me now on x-axis you put what? On y-axis you put what, Karin? Here you put what? Here you put what? Here is MV, RV. So who put here and who put here?
MV is x-axis.
Yeah, very good. The x-axis, you put MV. Yes, MV is here. MV, put it here, okay? The responding variable you put on R, put on Y-axis. Okay, thank you, Karin. Very good. Manipulated variable with a depth. Depth you must put here. So here responding variable is a L. Okay, put here. Don't make mistake, Once your x-axis, y-axis wrong, the whole thing gone. You can't afford to lose so many marks, Okay, the graph, okay? So make sure you do it correctly. Every time you plot any graph, also the same one. Manipulated sure must be X. The responding must be on the Y-axis. Okay. All right. Last. So your graph is like this lah. Okay. So plot a graph like this. So you say graph of L, the responding variable against a D is plotted. L against D. So you put here L against D plotted. So here is L in centimeter. So here, D is also in centimeter. Okay, put here. So then you plot the graph. Here, I cannot show you the graph because when you carry out the experiment, only you have to value to plot the graph. Okay. Okay, Jason. Okay, later on you watch the video, Jason. Okay. Okay, Jason, you can go now. Okay. Remember to follow the lesson later, okay. Okay, finish. Finish, everyone. Everyone so quiet here. Finish or not? Chan Yuan Yi, have you finished? Chan Yuan Yi?
Yes, sir.
Done, Okay. Zhong Zizhen, finish or not? Zhong Zizhen, finish. Okay, done, Yes, and one more thing I need to tell you all, I will only ask you all to go back to center for physical class by the month of April. I want you all to go back to the center, follow the school, follow school time. Okay, so when you go, you are allowed to go back to school during after 5th of April. So physical class in the tuition center also, I will only ask you to come back during the month of April. April only come back. Okay, I think it's better, safer like that, because now the number of cases is still high, every day still 2,000 something, 3,000 something. So we give another month, 1 more month. So after 1 month, I'm sure that the number of cases will drop to very low, then it's very safe to go back to face-to-face. Okay, so for the month of March, we still carry out online for the whole month, okay? Unless got final change, suddenly maybe during the month of March, suddenly the case drop so much. Maybe I will ask you to go back. But we see first. But for my initial plan, I only plan to ask you go back in the month of April, okay? Understand? Can one you understand or not? Can one you?
Yes, sir.
Understand? Okay. Okay, now start new lesson. Okay, come. I share the paper with you. New lesson. Okay, it's lesson 2 and 3 now. Chapter 2, lesson 2 and lesson 3 together. I combined it. Okay, your lesson 1, chapter 2, right? In lesson 1, you learn liquid pressure, correct? Not liquid pressure, we have just finished. Now in lesson 2 and 3, still pressure, but you learn gas pressure and atmospheric pressure. They are not the same. Gas pressure and atmospheric pressure are different things. They are different one. Okay? Okay, gas pressure why there is gas pressure? You only have gas pressure when the gas is captured in a container. Example, I give you one example. The cooking gas in your house kitchen. When you go to the kitchen, you can see the cooking gas in a cylinder, yellow color one or green color one. Inside the cylinder, you have a lot of gas inside. So this gas is captured inside a cylinder, then only got gas pressure. When you release the gas, the gas come out, then the mean no more gas pressure. So remember that gas pressure only occur when the gas is captured in a cylinder, in a container. Okay? The other one is atmospheric pressure. Atmosphere. This pressure comes from the atmosphere because surrounding us, the atmosphere is so thick, a few thousand kilometers, very, very thick. Okay? So definitely it will press on our body and then give us pressure. Okay? Okay, before we study gas pressure, there are few assumptions you need to know first. Basic things you need to know. Okay, come, let's go through quickly. These are the basic things you need to know regarding the gas. Okay, first, we call it basic assumption. Assumption means we assume it is like that. Actually, not we assume. We are nobody to assume anything. Actually, this assumption come from scientists. Scientists already carry out so many experiments, proven all these are correct. Then only they say assumption. We assume, he assumed this is correct. Okay. So first, highlight. Gases are made of tiny individual particles. Gas are all small particles. The volume of particles themselves is insignificant. Means the particles, the molecule of gas is too small. The volume too small. Okay. Compared to the volume occupied by the gas. In one big container containing the gas, right? The gas molecule is just too small, nothing. So therefore, we say gases are mostly empty. Gas are mostly empty one. Okay. Okay. Number 2. Gas particle move rapidly and randomly. This gas molecule will keep moving around. very, very fast, okay? In a straight line. Particles collide with one another and also collide with the wall of the container. So remember that. When a gas molecule captured inside a container, they keep moving non-stop, 24 hours, 7 days a week. This gas will not stop moving one. It will keep moving, right? So when a gas molecule moving, two types of collision can happen. One is collide with one another. One molecule collide with another molecule, okay? Another one is the gas molecule will hit the wall of the container. This is more important. Okay, collide with the walls of the container in elastic collision. All the collision are elastic collision. In Form 4, you learn already, right? Elastic, inelastic, cannot. Elastic means collide, it will bounce us back. Okay? Okay, number 3. Individual particles are far apart. So one molecule and another molecule, they are very far from each other, very far one. So meaning that no attraction between them. So they are free to move. Okay? Particles are considered move independently. So because of no attraction force between one molecule and another molecule, this one they are free to move. Okay, number 4. This one is very important. I want you to read, you tell me what is the meaning. Okay? The average kinetic energy of particles of different gases are equal at given temperature. What is the meaning? Can you read one more time? Average kinetic energy of particles of different gases are equal at given temperature. Meaning is what? You read one more time, and when I call your name, you tell me what is the meaning. What do you understand about this sentence? Okay, read one more time. Okay, come now. I call Yu Tong. Yu Tong, can you come out? Yu Tong, can you hear me or not? Yu Tong?
Yes, sir.
Yu Tong, can you read number 4 here? Can you tell me what is the meaning? What do you understand about point number 4? You
Specific temperature, the
uh-huh.
kinetic energy of all different gases are the same.
Yes, correct. Thank you very much, Yu Tong. What means by Yu Tong was this, actually, at a given temperature, we don't care what types of gas. Oxygen gas, carbon dioxide gas, hydrogen gas, or helium gas, we don't care. As long as the temperature same means all these different gases, they will have the same pressure, same kinetic energy. Okay? So I repeat again, we don't care whatever gas The gas, what types of gas is not important, Any gas also the same When they are in the same temperature means they have the same kinetic energy. The kinetic energy same Okay? When the temperature same, all the gases are oxygen, carbon dioxide, hydrogen, helium, everything they will have the same kinetic energy. That is meant by number 4. Okay? Important understand And number 5, average kinetic energy of gas particle increase as the temperature increase. This one is important. So basically we say kinetic energy of all the gas will increase when the temperature increases. Meaning that when the gas become hot already, so it will have more kinetic energy. It will move faster. Okay, common sense only Can Okay, now next one, I want to explain this one. Existence of gas pressure based on kinetic theory. Okay, now we are going to explain, why when you capture the gas inside a container, it will give you pressure. Why? Actually, what is the main reason gas pressure occur? This one you all must know. Okay. So you read here. Based on kinetic molecular theory, gas molecule move freely and randomly, says. The gas are non-stop moving on, the molecules. The gas molecule collide one another, we have seen just now, right? Collide one another and also collide with the walls of the container. There is a wall because you have a container, right? So two collision collision one with another or collide with the wall of the container. Okay, now the collision of gas molecule with one another is elastic collision. This one understand, okay? Nothing. Just collision only. Among one molecule with another molecule, just collide normal only, nothing happen. Okay? But most important is the next one. The collision of gas molecule with the wall of the container, this one is more significant. Collision of the gas molecule with the wall of the container produces change in momentum. Because change in momentum, you know why? When the molecule hit the wall, it bounces back in opposite direction. When move in opposite direction, so momentum change already. Change in momentum will produce impulsive force. In Form 4, you learn, right? Then definition of impulsive force is the rate of change of momentum. So when the molecule hit the wall, it bounces back, change in momentum happen. Change in momentum will become impulsive force. When this impulsive force act on the surface area of the container, force divided by area, you become pressure. This is how the pressure comes. Collision of gas molecule with the wall of container produces change of momentum and impulsive force. So gas molecule exert pressure on the inside container because pressure is force over area. So conclusion here, I talk so much already. The most important conclusion is one only. Is gas pressure occur because gas molecule collide with the wall of the container. That's it. When it keep colliding the wall of the container, right, it keep producing the impulsive force. The impulsive force act on the surface area of the wall, it become pressure. Okay? Whereas another types of collision just now, collision between one molecule with another molecule, these are nothing. No pressure one. The pressure only come from when the molecule collide the wall of the container. Understand? Karen Yong, do you understand?
Yes, sir.
Hui San, Tan Hui San, do you understand me? Hui San,
Yes.
Tan Hui San, can you repeat what I said just now, Hui San?
The collision between the gas molecule will produce impulsive force, and when the impulsive force act on the surface of the container, will produce pressure because pressure is force per unit area.
So meaning that the gas pressure only come when which type of collision produce a gas pressure?
Oh, collision between the gas molecule with the wall.
Yes, correct. Okay. Only the molecule collide with the wall. Okay, okay, thank you, Hui San. Okay, next one, conclusion. Please highlight the whole paragraph here. This one. The conclusion about the gas pressure. Gas pressure is force per unit area exerted by the gas molecule as they collide the wall of container. You see, only emphasize collide with the walls of the container. That's it. So gas pressure is produced from gas molecule when they collide with the walls of container. Okay, that's it. Yuan Yi, understand? Chan Yuan Yi?
Yes.
Chan Yuan Yi, you are using a big computer laptop
Yep,
or what? Laptop. Very clear you are using this headphone, so very clear. Clear or not?
Yes.
Okay, very good. Okay, next. Take out this diagram first. What happens if the volume inside the container decrease? So you look at the first container here, you have, I think it's 12 molecule of gas. So you follow here, copy exactly 12. So next one is you push the piston down to make the volume smaller, but the number of molecules still remains at 12, still the same. You compress, so the molecule here still the same 12. You copy this diagram first. Later we only see the answer, okay? Copy down the diagram first on the empty space here. Copy the diagram. Okay, finish. Now when you look at this diagram, over here, pressure 1 and volume 1. Over here, when the volume becomes smaller, pressure 2 and volume 2. I'm sure you know the volume 2 smaller than volume 1 because you compress. When you compress, this volume becomes smaller. So V2 smaller than V1. Okay, what about pressure? P2, P1. What happened to the pressure 1 and pressure 2? What happened? Karen Young. In your opinions, pressure 1, pressure 2, how? And for sure, we know V2 smaller than V1. What about pressure 2, pressure 1?
Pressure 2 higher than pressure 1.
Yes, very good. Pressure 2 sure higher than pressure 1. Why? Karen, do you know now why the pressure 2 become higher?
Because in pressure 2, the gas collide more frequently with the walls.
Yes, very, very good. Correct, Karen. Okay. When the space becomes smaller, volume becomes smaller. So more molecule of gas it will collide with the wall. So the frequency of collisions increases. Frequency collision become higher, so pressure become higher. Okay, copy this one. V2 smaller than V1, but P2 higher than P1. Okay. The reason is frequency of collision with the wall increases. When you have more like this, the molecule are closer, right? It will collide the wall more often. So frequency of collision is higher. Therefore, the pressure is higher. Okay, pressure increases. Okay, come copy. Okay, next one, copy this diagram. This one. This one is what happens if the number of gas molecule in the container increase. You increase, you put more gas inside. Put more gas inside here. Okay, copy this diagram. The two cylinders are exactly the same volume one. But over here, you only have 9 gas molecule. Here you have 15 gas molecule. You have more. you put more gas inside here. So more gas inside the same cylinder. So what happened to P1, P2? What happened to V1, V2, and why? These are the questions you need to explain. Okay, finish the diagram. Okay, now can you do like just now? You write one comparison between the V1, V2, another comparison between the P1 and P2, the pressure, and one more is a reason to explain your answer. Okay? Lau Quan Xuan, are you there, Lau Quan Xuan? Quan Xuan, can you come up, please? Quan Xuan?
Yes.
Quan Xuan, V2, V1, how? V1 and V2.
V1 equals to V2.
Yes, correct. The V1, V2 same. Then what about P1, P2? P1, P2, how?
P2 more power.
Yes, correct. P2, the pressure higher than P1. What is the reason? V2, P2 definitely higher than P1, the pressure here. But the reason is what? Quan Xuan, you know the reason or not? Why pressure 2 higher than pressure 1?
Frequency of collision with the wall increased.
Yes, correct. Thank you very much. So same answer actually. B1, V2 same, P2 higher than P1. And the reason same as above. The frequency of collision with the wall increases. When you put more gas inside, more collision happen. So frequency of collision increases, so the pressure increases. Okay, Okay, next diagram. Next one, you put fire to heat it up. This container got 9 molecules. This one also same 9. But here, normal temperature. This one, you put fire to heat up. So what happened then? You do the same. Write the comparison between V1, V2 and P1, P2. Okay, come. Do now. Okay, come. And for this diagram, what is relation between V1, V2? Volume 1, volume 2. Okay, let's hear from Rem. Rem Lee. Rem, can you come up, please? Rem? Rem, are you there? Rem, V1 and V2, how? Volume 1, volume 2. V1, V2 equal. Yes, correct. What about P1, P2? Rem, P1 and P2? P2 higher. Yes, correct. Thank you very much. Okay, we already know the answer. B1, B2 same, whereas P2 higher than P1. But why? How to explain pressure 2 higher than pressure 1 here? How to explain P2 higher than P1? Okay. Chloe Chu, can you come up please? Chloe, can you explain why P2 higher than P1? Chloe 出来
Yeah, sure.
Now you tell me why P2 higher than P1. When you heat up, what happened?
Because it expands when it heats up.
Yaka. When you expand, mean the V1, V2 cannot be same already. When you expand,
the gas particle.
when you heat up, what happened to the gas particle?
They move faster rapidly and then they
Yes,
will
right.
collide with the wall.
Yes, very good. Thank you very much. Okay, Chloe, exactly what you say. Okay. Bernard Howe also add there. Bernard Howe, no direct message. Bernard Howe send to for everyone, can or not? Don't be shy, Bernard. Let other people see your answer. Higher temperature increases the average kinetic energy. Also can. Actually, what happened was this law, you see, volume 1, volume 2 same, but P2 higher than P1. The reason is gas molecule move faster. When you heat it up, right, it will move faster. More kinetic energy, so it move faster, correct not? So what happens is you move faster, so frequency of collision with the wall increases. So end up pressure increases. Okay, copy the answer, please. Okay, finish. All right, next one we look at measurements of pressure. How to measure gas pressure. Okay, come. Measuring gas pressure. Okay, there are few methods to measure the gas pressure, First one is manometer. Using a manometer means the U-shaped tube so we can measure the gas pressure, Okay, so remember the name, manometer. It's U-shaped tube can use to measure the gas pressure. Okay, in the first case, you see here, this is a manometer. You put mercury here, or you put oil, or you put water, also can. And you want to measure the gas pressure is inside the container. The moment you open the tap, so the gas will push out and then push the mercury here, go down, here, go up, produce a different level. So by measuring the height here, you know the pressure already, correct not? So this is how we measure the gas pressure using a manometer. But in the case of this, right, the gas pressure is at this point. And you have to choose 2 points where you have the same pressure, So gas pressure is at here and is equal to the pressure at this point, same level. When level same means same pressure. You want to find gas pressure here, that means you must find the pressure on this side, same level one. So you can notice here now, the gas pressure is higher. You know why? Because gas pressure push this one go up higher. That means gas pressure higher than atmospheric pressure. So when higher, so you add up. So gas pressure is atmospheric pressure plus the pressure of these columns of mercury. So meaning that on the left side, you have atmospheric plus this column of pressure, then equal to the gas pressure. So gas pressure equal to atmospheric plus the pressure of H. Okay. And in second diagram, you can notice here, the moment you open the tap of the gas, right, you see actually this thing go up here. So it shows that the pressure of the gas actually lower than the atmospheric pressure. Atmospheric pressure is higher. So this is reverse, you see, atmospheric pressure will come in, push this thing go up, so this one go up higher. So very obvious, the gas here, the pressure is lower than the atmospheric pressure. When lower means you minus. That's why the formula is atmospheric pressure minus the column H. You get gas pressure. So remember when gas pressure like this is higher, so you add. When this one atmospheric pressure is higher because it pushes and go up here, so you minus atmospheric pressure minus the column H. Okay, and the last one equal. When you open the tap, you see no changes. No changes mean the gas pressure exactly same as the atmospheric pressure, so equal lah. Okay, so this one is manometer. Okay, now I want you to answer one question. Okay, can you look before this? Okay, look at the question. Okay, all right, the question here is saying, figure shows a manometer containing mercury. So you put mercury here, connected to the gas supply. So you see when you open the gas coming push here, this one down, this one up. Okay, that's okay lah. Then now the question asks, calculate the pressure of the gas in the unit cm mercury and in Pascal. So now, what is meant by pressure in cm of mercury? Hg is mercury. Pascal, I think you know. Last lesson you study already. Unit of pressure is Pascal. But now how come they ask for cm mercury? Okay, come. Let me explain to you first. You listen. Actually, the gas pressure can also measure in how many cm of mercury one. Okay, you look at here. Follow me here. There's a small diagram I want you to see here. This diagram. Here, class. Okay, look at here. You can see the diagram, isn't it? Okay, on this diagram, this is a tube, a long tube containing mercury. Hg is mercury, full of mercury, here full. So what happened is you inverted the tube and then put it on a container to allow the mercury to flow out. But you see here now, when the mercury will flowing out, right, it will stop at 76 cm. One time you stop at 76. You repeat another time, it still stop at 76. You repeat 100 times, 1,000 times, you get the same thing. Every time when you overturn the tube, the mercury will come out, but it will stop at 76 cm. Sure one, it will stop at 76 cm. And very funny. Why? Why the mercury will stop at 76? And why when reach 76, why it cannot come out anymore? It stopped already. Why? What is the reason? Okay, now I have a question to ask you. Who is there to stop the mercury from coming out? Why the mercury cannot come out anymore? Why? Sakti? Sakti, are you there? Sakti disappeared.
Yes, sir.
Sakti, can you tell me who is stopping the mercury from continue to come out? Why the mercury cannot come out anymore?
Atmospheric pressure.
Yes, very good. It's outside here you got atmospheric pressure. This atmospheric pressure stop the mercury from coming out. Don't allow the mercury to come out anymore. So you every time stop at 76 cm. Because your atmospheric outside here push. So they say mercury cannot come out anymore. So when scientists notice this thing happen every time, repeat few hundred times, every time also same 76 cm, 76 cm. So the scientists make a conclusion. He say the atmospheric pressure actually same as 76 cm of mercury. So he say atmospheric pressure actually equal to the pressure of 76 cm of mercury. Okay, so until now, so we just study only, people work so hard to find this one, then we just learn very easy in 2 seconds only. Okay. Okay, then what about when this mercury changed with water? I don't put mercury here, now I put water. So how do you think the water will become? How many? What is the height of the water? Okay, like this. When you put mercury, the atmospheric pressure can stop the mercury for the height 76 cm, can support the mercury up to 76 cm. When you change this one to water, right, it will become 10 meter, very high, because water is lighter, mercury heavier. So when you change with water, right, so this 76 cm now will become 10 meter. 10 meter is very tall, water. Okay? 10 meter of water. Okay? Remember now? So there are so many ways to measure and to express the gas pressure, okay? In cm mercury, in meter of water, and so on. Okay, go back to the question just now. And now I want you to answer the question. What is the pressure of the gas in terms of cm of mercury? It's given here. Atmospheric pressure is 76 cm mercury. Okay. So you look at here now. Who is higher? The gas pressure higher or atmospheric pressure higher? Which pressure is higher? The gas pressure higher or atmospheric pressure? Or maybe I ask like this lah. You plus or you minus to find the gas pressure? You plus or you minus? Chloe, you plus or you minus? To find gas pressure, you see the formula just now you learn, you plus or you minus?
Plus, teacher, plus.
Yes, correct. Karin say correct. Xing Yin also say correct. Gas pressure higher. Higher mean you plus lah. Atmospheric pressure plus this column law. So the answer is 91. Okay. Up here 76 plus 15, so become 91. 91 cm mercury. So meaning that the pressure of the gas here equivalent to 91 cm mercury, very high. Okay. And next one, they want you to count in Pascal. Then how you calculate in Pascal? Okay, like this. When you want the answer in Pascal, right? Okay, mercury is a type of liquid. So use liquid pressure formula lah. Liquid pressure you learn already, right? In lesson 1, rho Hg. Density, height or depth multiply gravity. You get the liquid pressure in Pascal. Okay, so what you do is like this. Okay, copy now. Mercury density 1.36 10 to the power 4. The height of the mercury now 91 changed to meter 0.91 times gravity 10. So you get this value 123,760 Pascal. Okay, copy the answer, please. Okay, finish, Okay, next one. Next one is another device, Bowden gauge. So to measure gas pressure, just now you learn manometer. And now the second one is Bowden gauge. Bowden gauge, huh? Right, this Bowden gauge are very simple, huh? I need 1-2 minutes to explain only, so you all listen. Where you can see this Bowden gauge, you can see it on this fire extinguisher. In school, I'm sure you have seen before the fire extinguisher, the red color one. On top of it, you can see a meter, a small round meter like that one. So this is Bowden gauge lah. This Bowden gauge is fixed on this fire extinguisher to measure the gas pressure inside. How this thing measure? So very simple. You just see. When the gas push in, right? When the gas push inside this metallic tube. This one is curved metallic tube, this is a tube made from metal. So this tube is a little bit soft one, not hard one, it will become strict, it will straighten it. At first was like this one, when gas go in, so it becomes strict, so it go up. So like this, go up, okay? Straighten, okay? So the moment the gas go inside, this tube will be straightened, so this part will move up. When this movement, right, will be transferred to here and to make the pointer to deflect. When this part moving, the pointer will deflect. So the pointer deflect to show the pressure. That's it, very simple. When the gas supply is stronger means here move more. It will move up more, right? When it move up more, it will deflect more. So that's all. Okay. Understand? Understand Bowden gauge? Okay. And I'm sure you have seen it before in the school, right? On this scale, you can see got red color, got green color. You must see the pointer, the pointer point to the green zone or point to the red zone, you must see. Why got green color and red color one? Why? Why on the scale got red color and green color? Then why? For what purpose? Why? Ati Supermaniam. Ati, can you hear me? Why does the meter here got green color, got blue color, green color, and red color? Why? Ati, she can't hear me now. The line internet not good. Okay, I think. Lim Jia Sing, can you hear me or not?
Yes.
Jia Sing, can you tell me why? Why the scale there got red color, got green color one? Here got blue, got red. Why?
Level.
Ati say too high dangerous. No, the red color, green color, not to show dangerous or not dangerous. No, there's another purpose. Why? Jiuling, please come. Jiuling, can you explain why got red color, red, blue, green color? Jiuling.
Is it like green, the pressure is very low, then red is very high?
Oh, yaka. Actually, what you say, Jiuling, was the reverse. The reverse, Actually, it's like this lah. When the pointer point to green zone, green stand for good things, right? Good things means the pressure of gas inside the fire extinguisher is enough. Still high pressure. High pressure means still got enough of gas inside. So when you see the pointer point to green means the fire extinguisher still can be used. Okay? When the pressure too low already, right? The pointer will go point to red zone, red color. When you see the fire extinguisher pointer point to red color means this fire extinguisher is useless already one, The fire break out also cannot use one because no gas pressure. When no gas pressure, you open up it, the gas also cannot come out. That's why it's very important. We have to check every single fire extinguisher, make sure the pointer point to green zone. When the pointer point to green means the pressure is still high, still valid, still can be used. When you see the pointer, next time you go back to school, you see the fire extinguisher. If the pointer point to red color means no point already. That one just for display only, cannot use one. Okay? Point to red color means the pressure is too low already. No gas already, no pressure. Understand? Julian, you understand? So there's red and green. Ati, now you understand, Ati? Okay, come, read here. Okay, Ati, thank you. Understand already. When a gas supply connected to the Bowden cage, connected to the pressure in the curved metallic tube will try to straighten it. The pressure trying to make this one straight, so it will move. Hence, the pointer will rotate because this part moving, so the pointer deflect. The magnitude of gas pressure can be read off the scale. You can read from here. Okay, Bowden cage. All right, next one. Another use of manometer. This one very important. Another use of U-tube. Manometer got another function one. Okay, highlight. U-tube can also be used to determine the density of a liquid. To determine density, not only measure pressure, can use to determine the density of the liquid. Okay, how? You see here now. So when you have two different liquid here, but these two liquid cannot mix up. They put together cannot mix one. Like oil and water, you put inside, it will become like that one. Cannot mix one. So liquid A is here, blue color. This one is density liquid B. By looking at here, you know already. This one heavier, it will go down. This one lighter, so it will go up. So we already know liquid B heavier, density higher. Liquid A lighter, so density lower. Okay, so to find the answer, right? You pick 2 points, same level one. One is here, one is here. Find the 2 points which are same level one. Okay, at this point, the pressure is P1. Okay, P1 is here, pressure 1. Whereas at this point, pressure is 2, pressure 2 lah. Okay, pressure 2. Okay, we know that P1, P2 same because they are at the same level. Okay, so you put here, P1 equal to P2. And then, to find pressure 1 is rho 1, H rho G, correct not? Height H1, density 1, and gravity. And same thing goes to here, P2, H2, rho 2, and gravity. So you get this formula. The gravity same, you can cancel off the gravity. And end up, you have this important formula. H1 rho 1 equal H2 rho 2. Okay? Remember, this formula is very useful. Given the density of one liquid, you can find the density of another liquid. Okay? So H1 rho 1 equal H2 rho 2. Okay? Important formula. H is the height of the liquid. Rho is the density. Okay? All right, now you look at this example. Can you follow the example? Go and find density of liquid K. Density of water given 1000. This one is water. This one liquid K. Density here is 1000. Okay, 1000 water. Then they ask you to find the density of liquid K. How to find the density of liquid K? Okay, use this formula. Come, you all do now. Tell me the answer. You have the answer, so you share your answer. Find the density of liquid K. Okay, do it now. Lee Jia-sing already got the answer. 250. Yes, very good, Jia-sing. Okay, thank you very much. Okay, now you see that the answer 250. Okay. Lee Jia-sing got it. Bernard Howe also got it. Thank you very much, both of you. Okay. 250. H1 is 20. Row 1, you're asked to find. H2 here 5 cm. Row 2, density of water 1000. So you get 250 lah. The unit for density is kilogram per meter cube. Okay. So okay. You know how to use the formula already. Okay, next one, we move on. Now is atmospheric pressure. Just now was gas pressure. Now it's atmospheric pressure. Okay, I want to explain this diagram. Later, I will ask you to repeat what I say. You all listen properly. Okay, this is our Earth. Surrounding our Earth, we have very thick layers of gas. There are all sorts of gas oxygen, carbon dioxide, nitrogen, right? So many gases, helium, hydrogen, so many. Okay, now you see, our Earth is something very good. We have the gravity. So the Earth will always try to pull the gas coming down. Because gravity is pulling anything in the sky, so we're pulled down by the gravity one. So the moment this gas is pulled by the gravity, right? So it turns into weight. It becomes weight, got weight already because gravity pulling down. So very thick layers of gas are sure the weight is very big one. When the gravity pull it down, okay, the weight is very huge. So what happens is, when the weight add on the surface area of your body, right, it becomes pressure. Weight is Newton, same as force. Force per surface area become new pressure. This is how atmospheric pressure come from. Atmospheric pressure come from the weight of the gas surrounding the Earth. Understand? Okay, highlight here. The gas molecule possess mass and experience the pull of gravity. The gravity pull the gas come down. The result is that gases have weight. Weight is Newton, same as force, isn't it? The weight of the gas molecule will produce force, and as a result, will exert pressure on you because pressure is force per area. Okay, please highlight. And this pressure now become atmospheric pressure. Okay, highlight everything, memorize it. Memorize it. I'll give you 2 minutes to memorize. Okay, when I call your name, so you answer. Okay, come. Huh? So when I call your name, so please don't hide yourself. You come out, please. Huh? Okay, Ming Yuan. Ming Yuan, can you come out? Ming Yuan?
Yes, sir. Yes.
Ming Yuan, can you tell me actually how this atmospheric pressure is formed?
Because the gas molecule process mass and experience the pull of gravity, and the gravity cause the gas have weight, and the weight
Uh-huh.
of the gas molecule will produce force and will result the atmospheric pressure.
Yes, correct. Okay. So weight is Newton. So the weight add on the surface area, so it become pressure lah. Very simple lah. Okay. All right. Thank you. Okay. Next part is even more important. Okay. This part I will take a little bit time to go through one by one. The characteristics of atmospheric pressure. There are few characteristics, Okay, this atmospheric pressure is so important for us, That's why you have to understand it properly. What are the characteristics of this pressure one by one? Okay, first one. Atmospheric pressure act equally in all directions. This is number one. Please jot down. Highlight it. That means atmospheric pressure act equal in all direction one. Top, bottom, front, back, okay, left, right, all same one. In equal in all directions. So remember that. Okay, point number two. This one is number two. Atmospheric pressure on an object, on any object, not depends on the surface area. You say? Atmospheric pressure on any object is not dependent on surface area, Okay, example is what? I tell you lah. One example is one person is very small size, surface area smaller. Another person is giant size, very big, surface area big. But both of them will get the same atmospheric pressure because atmospheric pressure treated everybody regardless your size, how big you are, how small you are, the pressure are all the same. Okay? So for small size persons, the atmospheric pressure is same as a big size fellow. Okay? Another one is let's say comparing ants, a small tiny ant and one big giant elephant. Both of them also will receive the same atmospheric pressure. We don't care the size of the surface area one. Same one. God is fair to everybody. Okay? Okay, that was number two. Okay, number three. Number three is here. Atmospheric pressure is influenced by the height of an object above the sea level. We call it altitude. So meaning that atmospheric pressure, how big or how small, right? It depends on the altitude. Altitude means how high from the sea level, seawater level. Okay? So as the altitude increases, you go higher. Altitude increases means you go higher into the sky. The atmospheric pressure decreases, the higher you go, the atmospheric pressure decreases because the higher it is from the surface of the earth, the lower the density of the air. I say like this the higher you go into the sky, there's lesser air. Not enough air up there. When less air means the weight of the air also become smaller. Smaller weight pressed on your body, of course the pressure becomes smaller. This is a reason. Okay? It depends on the altitude, The higher the altitude, the thinner the gas, the thinner the air. When thinner air means density air less so the pressure become less. That's why you see the balloon when you release a balloon the balloon go up into the sky, right? The higher the balloon fly, it will become bigger one because the atmospheric pressure becomes smaller, so the balloon will expand. expand, getting bigger, until one stage, boom, it will explode. Then the balloon disappeared lah. Okay. Okay, so third one is, remember, atmospheric pressure influenced by the height, influenced by the altitude lah. When altitude increases, atmospheric pressure decreases because higher from the sea level, the density of air lesser. Okay. And number 4. We do not experience the atmospheric pressure at sea level. We don't experience. Now you are sitting here, you don't experience the atmospheric pressure, right? Why? Because pressure inside our body same as atmospheric pressure. When they are the same, you don't feel it. We do not experience the atmospheric pressure at the sea level because pressure of body equal to the pressure of atmospheric, so same. So you don't feel it. And last, number 5. Okay, atmospheric pressure at sea level, at the seawater level, is equal to 1 atm. So many units. ATM stand for atmospheric pressure, 1 atm. Or 1 power 5 Pascal, 100,000 Pascal lah. Or just now we say 76 cm mercury. Or when you change to meter, water, 10 meter of water. So this is the last characteristics. Atmospheric pressure at sea level is equal to 1 atm, 100,000 Pascal, 76 cm mercury, or 10 meter of water. Okay. So remember now. Okay, 1, 2, 3, 4, 5. Okay, I give you some time. You go and memorize it properly. Okay, memorize it now. Later on, I will call you one by one. Okay, please memorize it now. Okay, read and memorize it now, okay? Okay, one more minute, okay? Okay, time's up. Okay, huh? Okay, come, listen here. Ngô Chinh Chân. Ngô Chen Chân. Can you come out, please? Ngô.
Yes.
Ngô. Okay, can you tell me one characteristics of atmospheric pressure? One only, just tell me one. Just one only can already. Tell me any one.
Atmospheric pressure acts equally in all directions.
Yes, correct. Act equally in all directions. Okay, thank you. Next one, Lim Yu Xuan. Lim Yu Xuan, can you come up? Lim Yu Xuan?
Yes.
Yu Xuan, can you tell me one more characteristics of atmospheric pressure?
One atmospheric pressure equals to 10 power 5 Pascal is also equals to 26 cm per mercury. 76 cm mercury.
And also equal to?
10 meter of water.
10 meter. And also one more is what? Got one more, 100,000 Pascal, 76 cm mercury, and 10 meter of water, and one more is 1 atm. Okay, you should understand?
Okay.
ATM is also 1 atmospheric pressure. Okay, thank you, Yushwan. Okay, next one. Jia Chuan, Lim Jia Chuan. Lim Jia Chuan, can you come out? Lima, can you tell me one more characteristics of atmospheric pressure? One more.
Atmospheric pressure is influenced by the height of an object over the sea level.
Yeah, is influenced by the height of an object from the sea level. Can you elaborate further how the height influence atmospheric pressure? How? Okay, maybe I ask another person. Nitilan, now Nitilan is your turn. Nitilan, please come out. Nitilan, can you hear me?
Yes, sir.
Nitilan, can you tell me now how this altitude affecting the atmospheric pressure? How?
As altitude increases, atmospheric pressure will decrease.
Yes, correct. What is the reason? Why the altitude increases, the atmospheric pressure decreases? The reason is what?
When altitude is increased, density of air is less.
Less A. When you go higher, right? Lesser A. Okay. All right. Thank you, Nitilan. And one last is Shi Qi. Yao Shi Qi.
Yes, sir.
Yao, can you tell me one more characteristics?
The atmospheric pressure is not depends on the surface area of the object.
Yes, correct. Very good. Not depends on the surface area of the object lah. Okay. And I think got one more. Okay, thank you, Yao. One more. One more I call Kanwan Yu. Kanwan Yu, can you come out? Kanwan Yu 出来嘛? Kanwan Yu One more characteristic is what? Atmospheric characteristic 还有一个没有讲的是什么？
不是讲完了没？
没有哦，还有一个嘞。
那个 do not experience the atmospheric pressure at sea level 那个。
对。
Because the pressure of the body equal to the atmospheric pressure.
Yes, correct. Because you don't experience the atmospheric pressure because our body pressure same as the atmospheric pressure lah. Okay, Okay. Okay, I think thank you. Everyone knows. Okay, now try answer example 3. Okay, I give you time to answer. Answer this question now. Okay, very simple. Atmospheric pressure 76 cm mercury. Calculate the atmospheric pressure in unit Pascal. And given density mercury, this one. So what is the answer? What is the answer of atmospheric pressure in unit Pascal? Okay, try 1 minute from now. So what is the answer? Anyone got the answer? Can share your answer or not? If any one of you got the answer already, please share your answer. I'm sure some of you got the answer, right? I still waiting the student to share. At least one or two students give the answer. Come on, please. Hurry up. Okay, finally got one answer came out. Wu Zizhong, you saved the life for everyone. Your answer is correct, perfect. Wu Zizhong, 103360 Pascal. Thank you very much, Wu. That's how you can answer. When you want the answer in Pascal, so use rho Hg, density 1.36 10 to the power 4. H 76 cm change to meter 0.76 meter. Gravity is 10. Then you get this answer. 103360 Pascal. And I told you just now, atmospheric pressure is near to 100,000 Pascal. This is very close to 100,000. Okay, then just now we see my characteristic number 5. 1.1 times 10 power 5. This one is round off one, you know. Actually, more accurate one is this one. 103360. Okay? This way, this is atmospheric pressure. But we round it off to 100,000 Pascal. Okay? Okay, example 4. Now, take your time, understand the question, and see how to find the answer. Atmospheric pressure at sea level is 760 millimeter mercury, while the atmospheric pressure on tops of the mountains is 600 millimeter mercury. If the density of mercury is this value and the average density of A is 1.25 only, calculate the height of the mountain. Okay, I give you a diagram. Use this diagram to find the answer. You look at this diagram. This is a mountain. At this level, pressure is 760 millimeter mercury. When you go up to the mountain, drop to 600 only. The pressure in mercury is 600 millimeter. Okay, now they ask you to find what is the height of this mountain. What is the height of this mountain? Okay, do it now. I give you a few minutes. Okay, try. Okay, tips is like this. You see, at here, pressure 760 millimeter means 76 cm mercury. When go up to the mountain, it become 60 cm mercury only. So meaning that from here to here, the difference is 16 cm. Okay? 16 cm in mercury, you know. When you change 16 cm mercury into A, this one is A, when you want to find the height here, it become the A. Okay? So it become how many cm? 16 cm mercury, the difference. And in difference in the A, it become how many centimeter? Can you calculate? Okay, any idea? Okay, come, let me explain. Okay, come, look at here. Actually, we say pressure of the gas same as pressure of mercury. Someone give the answer here, I see. Yes, same, Juling, correct. Thank you, Juling. In terms of gas, the pressure must also same as in terms of mercury. So you say pressure of the mercury 16 cm must same as the pressure of gas how many cm? So rho 1 H1G, rho 2 H2G cancel, so you get the G can be cancelled off. Gravity both same. Density 1 here is A, 1.25. You want to find the height of the mountain is the height of the A. And now density of mercury, this value. And the height of mercury different here is 16 cm. By calculating this, you get 174080 cm. Change to meter, you get this. So the height of the mountain is 1740.8 meter. Okay? So got it, huh? Okay, quickly copy down the answer. Okay, come, we move on now. Okay, next one. We look at a few examples. How to prove that the atmospheric pressure is there. Because I tell you why, atmospheric pressure, we talk, only actually they are surrounding us, but we cannot see, cannot smell. Then how to prove got atmospheric pressure? So you must have something to explain there is atmospheric pressure in the sky. So how to do it? So look at this experiment. Okay, this experiment is one of the famous experiments to show that there's atmospheric pressure, Okay, you are using a cup, a glass, fill up with full of water, so you have water, use a cardboard to cover it. Use a cardboard cover. So over here got full water, got water one full. Okay, use a cardboard to cover it tightly. After that, you overturn it. When you overturn it like that, you notice that the cardboard and the water wouldn't drop one, it will stay inside the cup, stay inside the glass. And also the cardboard never drop. Why? Why when you overturn the glass, the cardboard will not drop and even the water also cannot come out? Okay, the explanation is this, The moment you fill up the glass with water, right, you already displace the air. You already force out all the air inside the glass. Meaning that actually inside the glass there now has no air. Or we say lesser air lah. When lesser air means the pressure become lower. You know, right? Vacuum pressure 0, 1, no pressure 1. So when lesser air means the pressure become less. So inside pressure become low. So what happens is this law, when you overturn it, outside atmospheric pressure is higher. Inside here, because become low pressure. Why low pressure? Because the water has forced out all the air. So less air inside, so it's partially vacuum. So it's low pressure. So inside low pressure, outside high pressure, so it will push. You have a force different in the pressure, produce a resultant force. So this resultant force will support the weight of the water and also the cardboard. So higher pressure outside will prevent the water and the cardboard from coming out. That's it. This clearly shows that atmospheric pressure is there. Okay, come read. Fill the glass to the top with the water and wet the rim. Okay, wet the rim in the side, you have to wet it now, okay? The cardboard on the top, hold the card firmly, place and turn the glass over. Take away your hand, okay, highlight. The cardboard does not fall and the water remains in the glass. Okay, why? Explanation is here, highlight. The explanation for this phenomenon is that the resultant force caused by the atmospheric pressure act on the surface of the cardboard greater than the weight of the water. Okay, you can support the weight of the water and the cardboard. It's because resultant force caused by difference in the pressure. So outside high pressure, inside low pressure, difference in the pressure produce a force. We call it resultant force. This resultant force can support the weight of the water and the cardboard. That's why it can prevent the water and the cardboard from coming out. Okay, I have a question to ask you. Why this experiment only successful when you fill up the glass full with water? full with water only you can one, you know. When you don't fill up fully, you cover it, you overturn, you see can now. Sure the water come out one. Sure the carbon drop. Okay, why? Why you must fully fill up? You don't fully fill up, it tak jadi one. Why? Can someone please explain why? Wu Ji Zhong, can you explain why when the water not full, you cannot do this one? Why? Now, Wu Ji Zhong.
The gas molecule push the water out.
Why lah? Why must full with water only? If not full water, why cannot?
So there's no more gas molecule in the cup.
No more gas molecule. When there's no more gas molecule?
When the glass is filled with water.
Yeah, correct. When fully filled up with water means you already force out all the air. All the air you force out already. So the pressure become very, very low. No more air. So very low pressure lah. When not fully filled up means you still got air inside, you know. When you still got air inside, meaning that the pressure will not so low one. Okay, What is happening there? Pok. Okay, so I think I stop here. So you all understand this example. This is an example clearly show that the atmospheric pressure is there now to show that it can support the water, prevent the water from coming out. Okay, I stop here for tonight. Okay, anyone here got any question or not? Gong Fan Xin, anything to ask? Simeon, anything to ask? Simeon?
No, sir.
No question. Sing Yin, anything to ask or not? Sing Yin?
No, sir.
No, sir. Okay. Yi Peng, any question to ask? Yi Peng?
No.
No, Yuan Yi, Chan Yuan Yi, anything to ask?
No, sir.
No. Brian, what about you, Brian?
No, sir.
No, sir. Okay, Okay, if no question, nothing to ask. Okay, you can go take a rest now. Okay, I see you next week. Take good care of yourself now. Okay, bye bye everyone. I see you next week. Okay, bye bye.
Thank you, sir.
Bye bye. Bye bye.
Thank you, sir.
Thank you, sir. Bye bye. All right. Bye bye. Okay. Bye bye.
Thank you, sir.
Yeah. Bye everyone.